Okay, so coming into our first question here, it says we're going to use this Pythagorean theorem to find the missing side length of a right triangle. Let's go to the show your work section here and then minimize your answer spaces because we got to talk about what this is real quick. So this is probably one of the oldest and most well-known geometric theorems, the Pythagorean theorem. If you're not already familiar with it, you will be very familiar with it by the end of this class because it is so useful in terms of what we talk about in geometry. So first thing is to understand this. We use this Pythagorean theorem to find the missing side length of a right triangle, the missing side length of a right triangle. And I want to take a second and just make sure that I highlight, box in, or clarify this word right triangle because we've been classifying our triangles, right? So which kind of a classification is this? Is this an angle classification or a side classification? This is an angle classification, right? Because it's the right angle in the triangle, all right? And so the angle classification for a right triangle allows us to use the Pythagorean theorem to find a missing side. You see it? There it is again. Angles related to sides. Sides related to angles, right? So Pythagorean theorem is a side math problem, but we can only use it in a certain angle classification. It doesn't work with every triangle. Doesn't work with obtuse triangles. Doesn't work with acute triangles. Doesn't work with equal angular triangles. It only works with right triangles. Now, in this picture over here, you can see that the legs have been labeled with an A, a B, and a C. This is a common way for us to write the Pythagorean theorem. And so what you need to know is when we talk about the sides A and B, we call those the legs of the triangle. The legs of the triangle. And so what's important to understand about the legs of the triangle, we'll draw a little arrow going this way, is that these meet to form the 90-degree angle. So the legs are the two sides of the triangle that meet to form the 90-degree angle. Okay, so A and B here meet to make the 90-degree angle, and so we call those the legs of the triangle. Now, side C is the side of the triangle opposite the 90-degree angle, which is called what? We just talked about it the other day. That's your hypotenuse, right? This is where this comes into play. This is our hypotenuse, which is the side opposite the 90-degree angle, right? Opposite the 90-degree angle. And as we talked about in our classification, this is always going to be our longest side. Why is it the longest side? Why is the hypotenuse always the longest side? Somebody tell me why the hypotenuse is always the longest side. Give me a quick hand. I got this, Mr. Fargus. I know why the hypotenuse is always the longest side. Come on, somebody's got to have this. We just spent a lot of time talking about it. Why is the hypotenuse always the longest side?
Because legs A and B, they extend out very far, and the longer it extends out, the longer the side gets.
Good try. Why is the hypotenuse always the longest side? Why is the hypotenuse always the longest side? Uh-oh, you guys weren't paying attention in the last lesson. What's that? Opposite of what?
90-degree
Okay, the 90-degree angle, but it's opposite of the largest angle in the triangle, right? Largest angle projects the longest side. Again, connection between angle, size, and side measurement, right? That's what I was doing up here with this, right? Angle, size, and side measurement. All right, so let's talk about what the Pythagorean theorem is mathematically. And it is our a squared plus b squared equals c squared, where a, b, and c are the lengths of the sides of the triangle. So we're going to do A and B and C. We're going to multiply each of those lengths by themselves. We're going to put them in this formula, and we're going to figure out the missing side length. That is the objective for our Pythagorean theorem. Okay? So then here is our right triangle. And again, sometimes it's helpful to identify the legs. You can mark them if you want. Like I like to kind of mark my legs every once in a while. It helps me to see leg, 90-degree angle, leg. So now I know what goes where in my problem. And in this case, I am missing my hypotenuse, right? So to figure out my missing side length, I'm going to first set up my Pythagorean theorem. So it's going to be a squared plus b squared equals c squared. So it's going to be 8 squared plus 13 squared equals squared. Okay. Now, the quicker you can do squaring numbers in your head and not be reliant on a calculator, the easier these problems are going to go for you. However, if you need to write them out on your calculator, feel free to do that. All right. Now, 8 squared is 8 times 8, not 2 times 8. Make sure you get that right. So that's 64. And then 13 squared, 169. By the way, 13 squared and 14 squared are really easy to remember. 13 is 169. 14 is 196. Flip the last two numbers. 13 will always be the smaller one. Okay. All right. That is equal to our I don't know squared. So now that we've done our squaring of our numbers that we can, we're going to add up our terms here. So 64 plus 169. You guys do that for me. What do you got? 233 is equal to x squared. And then we are going to take and calculate the square root of that number, right? So we're going to ask this question of both sides of our equation. Make sure you write that in your work. That question again is, what times itself gives me, whatever that is inside the square root sign. So what times itself gives me x squared? Well, that's just x. And then what times itself gives me 233? So on your calculator, depending on how your calculator works, you'll either do the square root sign first, or you might have to type in the number and hit square root. And when you do that, you should get, let's see, I'll give you the whole one here. Hold on. Yeah, the square root of 233 is 15.2643375247, blah, 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 blah. In fact, that's going to go on forever and ever and ever. It's not going to repeat, and it's not going to stop. And that's what we call an irrational number. And all non-perfect square roots are irrational numbers. Now, if you open up your little answer sheet over here, you'll notice that it says round answers to the nearest tenth if necessary. So in this case, we have an irrational number. It is necessary, right? So if we're going to round 15.26433 blah, blah, blah to the nearest tenth, it's going to round as 15.3. And that would be our answer for number 1, and you can type that in. Now listen, I put x equals 15.3. Really, if I was going to be a stickler, I should say x is approximately 15.3, but the thing is we're so used to writing x equals that that just gets missed by the wayside, and I don't want to hassle with it. So we're just going to say x equals, but you need to understand that it's not the exact answer. In fact, this right here is what we would call the exact answer, and there will be a point where I ask you for the exact answer, and that would be the answer inside the square root sign. Okay, that won't be today, but that's coming. And so when I ask you for the exact answer, you give me the square root. But when I'm asking for the approximate answer, that's when you would give me a decimal rounded to whatever place value you're asked for. How are we doing so far? Everybody okay? Good? All right. So when it comes to writing out your work, this is what I expect to see. Something that looks like this. I expect to see first your Pythagorean theorem set up. Second, I expect to see you square out whatever numbers need to be squared out. Third, you can do your summing and solving. And then last, I expect to see your square root signs on both sides of your equation to give me that answer that you're looking for, okay? That's what I'm looking for on the work. Make sure you practice it so that you don't get marked down when you don't write out all the work on test day or even when I grade your homework. Okay, good. Let's try one. All right. So now you guys have numero deux here. So I'll give you some steps along the way, but why don't you go ahead and start working on setting up your Pythagorean theorem. Okay, so if you're moving in the right direction, you should have been heading here. Does it matter if I write it 27 squared plus 22 squared or 22 squared plus 27 squared? Nah, it's an addition problem, right? Commutative property of addition allows us to move that around. Next level of work should have looked like this here. Next level of work should have looked like this here. And then you show me the square root signs, like that, like that. And then rounded to the nearest tenth, you should have gotten 34.8 is equal to x, and then type that into your formative space here. How'd you do? Get that all right? Okay. So we're using Pythagorean theorem to find a missing side on a right triangle. So we have to classify it by angles, but we're doing side work. Okay, important that we keep that clear. Okay, let's see what we got next. Okay, let's see if you can set up your Pythagorean theorem correctly for this question here. Okay, let's talk about something for just a second. Stop where you're at and check and make sure you set up your problem correctly like this. Yes? Now listen, I don't want to see this written as a subtraction problem. Pythagorean theorem is a squared plus b squared equals c squared. So the subtraction comes in the solving of the problem. You write this leg squared plus leg squared equals hypotenuse squared. And then you work out the rest of the problem, okay? But be aware of which side you're missing and you're looking for. And again, you can write this x squared plus 7 squared equals 9 squared. However you want to write it, that's fine. But your hypotenuse always needs to be by itself on one side of the Pythagorean theorem. Okay, for number 3, you should have come up with this right here. Take a look and see how you did. All right, step up our game just a little bit. Let's see what you could do with this one. Now, let me just give you a suggestion. If these questions get a little complicated for you, you can always start off like this. Watch up here. You can always go leg squared plus leg squared equals hypotenuse squared. And then you can identify where the legs of your right triangle are, like here, 90, here. And then fill in your parentheses with those values and then keep track of those in your calculator. Let's see what you do with that one. Go for it. Okay, so let's talk about this real quick. Here we go. So, okay, so listen. We only round irrational numbers. Okay, we only round irrational numbers, so keep that in mind. If you have a number that is a terminating decimal, we don't round that terminating decimal. Okay, so just sort of keep that in mind as we're looking on it. Okay, all right, we good so far? Pythagorean theorem? No? Yes? Maybe? Okay. All right, let's step our game up just a little bit. All right, so here we have now our refresh your browser. All right, so now we have an interesting situation, and we've got the notes up there to help you continue along with this, right? What kind of a line is that dashed line right there? No. Okay, so it starts at a corner and meets the opposite side at a right angle. Begins with an A. Altitude. And what center of the triangle is made from the intersection of the altitudes? That's orthocenter. All right. Okay, now, some things to know. Okay, some things to know. So here's the deal, right? You can see that we have two congruent sides here. So we have an isosceles triangle, right? Okay. So in that particular case now, we have a line that bisects an angle. So that's obviously our perpendicular bisector line, right? This is our perpendicular bisector line, which is the altitude of the triangle, which means that our base is cut into two congruent parts, right? Because our bisector line is going to cut that 22 into two congruent parts. And that's what you need to be able to recognize in order to use your Pythagorean theorem. So let's see what you can do with Pythagorean theorem here.
Is this also the Pythagorean?
Okay, let's see you got the right setup. You should have figured out that this is what you're going to use here to find your missing side lane. So here's your right triangle. I didn't write it through the side. I could see why you might think that was a congruence mark, but actually I didn't write it through the side. But I also was talking at the same time that I said that it was cutting that 22 in half. So that should have registered that it was 11. Okay, all right. So now you see it. That's why we're practicing these here. Okay. Okay, let's take a look and see how you did. You should have come up with this right here. Right? Good. Doing okay so far? Okay, so we're kind of hiding our right triangles in here a bit. Question.
So why don't we use the right side? Because I originally had set it up for the right side of the bubble. Having 24 and 11 be the sides.
Well, it's the same thing, but X and 11 are the legs, because in either triangle, whether you're talking about the one that's highlighted here or the other one, the X length and the 11th length meet to make the 90-degree angle. That's why those are always set up as the two that are being added. Yes?
Oh, no. I was going to say, why would we times it by 2, but the squaring is like making it both sides.
Well, the thing is remember, if we... Okay, hang on. This is a good question. Shh. Listen up. This is a good question. So we can't use the 22. Is that what you're saying? Like, what we multiply by 2?
No, I'm saying, like, since there's two sides to that triangle, isn't that what the squaring is doing?
Well, no. What the squaring is doing is something completely different. But I don't want to get into all the details of that. But we could talk about that later. Today is more like, how do we run the machine? We could talk about how the machine's built later. But you can find it on the other side. You would have to just notate that there's a 24 over here, and then it would be X and this 11 and 24, but it's still going to end up being set up the same way.
So is the 21.3 only half of that triangle?
The 21.3 is the length of this dashed line segment right here. That's what we're finding, right? Because we're finding the length of a side of a right triangle. And whether that's the highlighted triangle, the non-highlighted triangle, that's still the same side. Okay, good questions. Good question. Yeah, right. Yeah, exactly. But we're not looking for area. We're looking for the length of a side. Okay, all right. Let's try another one. Okie dokie. Let's see what we got going on here. All right, now we have some right angles, but we don't have a right triangle necessarily.
You can't see.
It's frozen. You forgot to freeze it.
There we go. Okay, we're looking for this length right here, but this length isn't part of a right triangle yet. But what if I took and I just drew a matching line like that? Well, these two lines are going to be the same length, right? I'm just matching another line there. And that means that this is going to be a 90-degree angle here. And so now we can see our right triangle that we can use for this problem is going to be here, here, and here. Okay, but here's the question. Here's the question. We're looking for a leg, right? Leg is x. Hypotenuse is 16. What's the length of the other leg of the triangle? 13? I don't see a 13 up there.
18 minus 5.
Oh, okay. All right. I see what you're saying. So what you're saying is that this 18 runs the whole length here, but we have to split that into 13 and 5. Does that make sense? Okay. So you have to do a little cut and pasting here to find it. All right, let's see if you can get the right Pythagorean theorem problem set up. Let's see how you do. Okay, if you're moving in the right direction, you should have started with this Pythagorean theorem problem right here. All right, now finish it up. Okay, if you're not quite there yet, let me give you a little snapshot of what it should look like. Here you go. All right. Questions? You see what I did here? Took that shape and cut it up so that I could get a right triangle out of it so I could use my Pythagorean theorem along those lines. Okay? All right. All right. So now we're faced with this hoopla. Okay, hang on real quick. Let's lock it in. Okay? Focus. Now, in the last one, let's just go back here for a second. In this last one, we took this whole length of 18 and we broke it into two pieces, right? We broke it into the 13 piece and the 5 piece. So if we wanted to find the whole bottom side of this triangle here, that's units long, we could break that into an A piece and a B piece, like that. And if we added those two together, we would get the whole length across the bottom. Okay, I'll let work on this one. Ready, set, go. I don't need to help you. I've given you all the help you need. Okay. All right. Here's my little hint for you. Help. I'll give you this. Right? Because what I'm doing is I'm finding the area of the right triangle on the left part, and I'm finding the Pythagorean theorem to find the side length on the right part. I think I said area, I don't mean area. So the A side length and the B side length. All right, that's all the hints you get. You guys got lucky. It wasn't on freeze.
I was paying attention.
Yeah.
I was trying to do my own work.
That's good. I like that. I like that. You should be doing your own work. I like that. So again, we found the length of A by doing a Pythagorean theorem problem. We found the length of B by doing a different Pythagorean theorem problem. And then we combined those together. A plus B equals that whole length of X. And so this is how we're kind of complicating it up a little bit with our Pythagorean theorem questions. All right, I'll give you about 30 seconds to get that finished up if you're not done. Okay, you got it? If you got it right, you should have put them here, right? So again, we've drawn a context picture. We've created our house. Our roofer has leaned our ladder up against our house. Our ladder is 16 feet long. The base of the ladder is 5 feet from the house. How high up the house does the ladder go? And now you do Pythagorean theorem to figure out that answer. You should have come up with 15.2 feet. Now, I actually included on the formative, I included the unit for you to help you out. So you really only need to put the 15.2 in the formative. So don't do the feet. I've already put it on the formative. You can see it is right there. What's that? No, I don't think so. I'm probably not going to do that. I'll let you know if I do. Let's take a look at our next question. Kurt is building a rectangular deck. If the dimensions of the deck are 10 feet by 23 feet, what is the diagonal of the deck? Okay, so it's rectangular, so that's pretty easy. So maybe something like this. I'll make it sort of deck-looking-ish. You know, like that. I don't know, you know. Kind of deckish looking. Like something like that. Okay, now what we're looking for is the diagonal across the deck, right? We're looking for the diagonal across the deck. So maybe I use a different color just to help myself out here, and I draw a diagonal line like that across my deck. Okay. And then we have our dimensions of 23 feet and 10 feet, and I will let you figure out the rest. Okay? These types of questions tend to confuse students a little bit, so we can take a look at this one together. Okay, it says Ashley jogged 3.4 miles east, then 5.7 miles south. How far is Ashley from her starting point? So here's my recommendation. Here's what I would do if I were you. I would start with something like this. And then this, and then this, and this, and this, and this, and then this, and then this. Where do you think that Ashley started jogging?
X.
I don't even have an X on there. At the origin is where Ashley started jogging. Right, exactly. So we could put Ashley's starting point here at the origin. And then she goes 3.4 miles east. So that would be this direction here, right? So she goes this way. and that's 3.4 miles. And then she turns and she goes 5.7 miles south. So that would be this way. That's 5.7 miles south. Now, when the question asks, how far is she from her starting point, it's asking what is that shortest distance from her starting point, which, of course, would be this distance here, which would make this here and this here, and you should be able to figure it out from there. So here's what you should have calculated out with this one. All right, we got one more to do.
I don't like you.
Okay, here we go. A 31-foot support wire is attached to the top of a 25-foot telephone pole to a point on the ground. How far from the base of the pole does the wire meet the ground? Okay, well, let's maybe start drawing some pictures and see if we can figure it out, right? So let's start with some ground. No. Let's start with some ground. And we need a telephone pole. There we go. There's a telephone pole. Now we have a support wire attached to the top of a telephone pole to a point on the ground, and that ground is some distance from the base of the pole. Okay, so that's probably going to be like out here somewhere, right? Because it's got to be some distance from the base of the pole. So then that means that that wire is going to stretch from the top of the pole down here to that anchor on the ground. And that should make a right triangle stand out to you. So now we just need some measurements, right? Like we know that the wire itself is 31 feet. So where does the 31 go? Why don't you write it in? It's a 31-foot support wire. So here's the wire, right? It's 31 feet, and it's attached to the top of a 25-foot telephone pole. That's how tall the telephone pole is. So that would have to go here. And what are we looking for? We're looking for the distance from the base of the pole to where the wire hooks to the ground. That would make sense, right? And you should be able to figure it out from there. Looking pretty good. So you should have come up with this right here, 18.3 feet. You calculate out your Pythagorean theorem. All right. So your homework for this lesson is to finish the Pythagorean theorem classwork assignment that we started today here in class. So if you finished it, then you have no homework. Yes. As long as it's done. But if it's not done, or if you missed any parts, you need to go back and finish those parts. But you do have a few minutes now and time.
Can you unlock it so we can submit?
I will do that. One other thing to keep in mind, don't forget you have 2 assignments due tomorrow, though, right? You have the classwork and the homework for classifying triangles. So if you need to use your study time tonight to get those done, make sure that you get classwork and homework completed to 100% for the classifying triangles lesson. One more time, let me say it so everybody's clear. Classwork and homework must be done to 100% for your classifying triangles lesson. Okie dokie. Happy Thanksgiving.